If we jump down to question number 5, our first question is always, are there any variables whose coefficients are opposites? In this case, the coefficient of x in my first equation is 2, and the coefficient of x in my second equation is 1. They're not opposites. My coefficient for y in my first equation is 5, and the coefficient for y in my second equation is also 5. They're the same. They're not opposites. In this case, we can create opposites in one of the equations by multiplying everything by a -1. I'm going to leave my first equation exactly how it is. But I'm going to take my second equation and I'm going to multiply everything in that second equation by -1. X times -1 would be -x. 5y times -1 is -5y. And -10 times -1 is +10. By multiplying the second equation by -1, I've created a situation where the coefficient of y now are opposites. I can use elimination by just adding these two equations together, remembering that I can only combine my like terms. 2x plus a -1x is just x. 5y plus a -5y is 0. We've eliminated the y's from our equation. And 0 plus 10 is 10. Remembering, of course, that finding that x is equal to 10 is only half of my solution. I still need to find the value of y, and I can choose any equation to plug that x value in. Out of habit, I always just use the first equation, but you could certainly pick the second equation if you prefer. I just found out that x was equal to 10, so I substitute 10 for x into my equation. And then we use the order of operations to solve this system of equations. To solve this linear equation. 2 times 10 is 20, plus 5y equals 0. We can subtract 20 from both sides. And we can divide both sides of my equation by 5 to find out that my y value is -4. Again, my solution to this system of equations is a point, an x and a y value that graphically represents the point where equation 1 and equation 2 intersect each other. But it also represents an x and a y value that if I plug into either of these equations would give me a true statement. Remember that the key in this problem was the numbers, or the coefficients, were the same, but they were not opposites, so our strategy is to multiply just one of the equations by -1. It doesn't matter which equation I use, just one of them. The same thing is going to happen in question number 6. I have coefficients that are the same, they're not opposites, so I'll have to multiply one of those equations by -1. And in number 7, my coefficients for x are the same, I'll have to multiply one of them by -1. In question number 8, my coefficients of y are the exact same, not opposites, so I have to multiply one of the equations by -1. But don't just get stuck in that habit. If you take a look at question number 9, my coefficients for y already are opposites. I have a coefficient of -4 and a coefficient of +4. I can just go ahead and add these equations like I did in my first example.